Okay, so we graphed cosecant, which was just a reciprocal of sine. And we have vertical asymptotes to represent where it's undefined. All right, and we have these nice U-shaped graphs. And then we graphed secant, which is just a reciprocal of cosine. Looks just like sine, except it's, or looks just like cosecant, except it's just shifted over. Okay? So we're going to look at doing some transformations then using those graphs. Okay? So number one says to graph -3 cosecant of t. So first thing we're going to do is you'll notice that the scale I have on here is going from -8 to 8. All right, because we're multiplying by 3, that means we're going to stretch it out 3 times more. So our graph then, first of all, since we're doing cosecant, we put our scale on here. So we're going to do pi, 2 pi, negative pi, negative 2 pi. Right. Now, cosecant has asymptotes at all of the pi's. Our domain for cosecant is where x is not equal to pi over n. So we're going to put those asymptotes on here first. So at all of our pi's. Now, this says -3 cosecant of t. So that means what? What's the negative tell me is going to happen? Okay, it's going to be a reflection over the x-axis, so we have a vertical reflection. So wherever in my original it's positive, in this graph it's going to be negative, except all my y values are going to be what? 3 times greater. Okay? So at pi over 2, we'll go there. All right? So at pi over 2, we had positive 1. So at pi over 2 on this one, it's going to be what? -3. All right, because we're taking that positive 1, we're going to multiply it by -3. So this is going to be at -3 at pi over 2. Now the other numbers that we used were pi over 6 and 5 pi over 6. And we said at pi over 6, since sine was 1/2, cosecant was 2, so then -3 cosecant means it would be at -6. So I'm going to have it -6 there, and -6 over here, and then we'll draw our graph. Oh, I don't like that. Get rid of that. It's too fat. There we go. Okay. And so then our points we're going to use, here we got -3, -6, -6. So when I cross over the asymptote, remember one of the things we talked about is when I cross over an asymptote, if I finished at -infinity, when I cross over I have to go to positive infinity. So that means when I cross over, then I'm going to have the points at +3, and the outer points then would be at +6. So all I'm doing is taking those y values I have from my original and multiplying them by -3. In this other example, we're going to graph 3 secant of t plus 2. So not only are we going to multiply the y values by 3, we're then going to add 2 to them. Right? So we're going to have a graph that looks just like this one here. When I'm done, it's going to look just like that, except it's going to be stretched out. So all my y values are going to be 3 times greater than they are. But then I'm going to take the whole graph and I'm going to move it up 2 also. Okay? So let's start and look at these. So we'll set it up first of all. So I put my scale on here again. I'm just going to do the pi's, right? Because we know the in between them is the pi over 2's. Now by vertically stretching this and shifting it up, is it going to change where the asymptotes are? No, it's not going to change asymptotes because I'm still going to have the reciprocal of cosine at each of those points. So because I'm not moving it horizontally, this is all vertical stuff, since I'm not moving it horizontally, then my asymptotes are going to stay in the same place. So my asymptotes are going to be at all the pi over 2's. Okay. All right. So let's look at 0. At 0, secant is 1, right? All right. Right here. At 0, secant is 1. So if I multiply 1 by 3, I get 3, and then I add 2, and I get 5, okay? So this is going to be at 0, it'll be at 5. I multiplied 1 by 3 and then added 2 to it. Okay. Now our points on the edge then, okay, those were 1/2, right? For cosine. So if I take the reciprocal of cosine, I get 2. 2 times 3 is 6, plus 2 is 8. So these are going to be at 8. Okay. Okay. Now let's look at the negative ones. Now that's a little bit harder, right? So if we look at the negative ones, here we have -1 here at pi, right? What do I get when I multiply -1 times 3? I get -3. And -3 plus 2 is -1. So we're going to be at -1 here at pi. On our outer points up here, we have -2, right? -2 times 3 is -6, and -6 plus 2 is -4. So then these are going to be at -4. And then we go ahead and finish it from there. So the big thing is using your y values from your original and multiplying them and doing any adding you need to. So these we were looking at vertical stretches, reflections, and vertical shifts. So that's the reason why we did the original graph, is so then you can just go to those original graphs, redraw them, okay, All right? And then use them to do your transformations. Okay, so here's the graph of cotangent, which we can think of that as the graph of 1 over tangent or cosine over sine. Either way, it will give us the same thing. Looks very similar to tangent, okay, with some variations. The domain happens to be the same as cosecant because both cosecant and cotangent have sine in the denominator. So their domains are going to be the same. And the range, just like tangent did, is all real numbers. Okay, so here we have a little bit more complicated graph. Right? We have a reflection, vertical stretch, and a horizontal shift. So now we're going to do some horizontal work with this also. Okay? So let's write down, first of all, what are the transformations that take place here. We have -4 cotangent of t plus pi over 2. What's this negative out front tell us? Okay, so first we have a vertical reflection. Okay, because of the negative. All right, what's the 4 do then? Okay, so then we have a vertical stretch. By a factor of 4. Okay, so that means that all of our y values then are going to be multiplied by -4. Okay, well then what does the x plus pi over 2 do to it? Okay, it's going to be a horizontal shift. Okay, pi over 2 to the left. Okay, so we have a horizontal shift left pi over 2. Okay. So remember, all that stuff comes from our general formula, which is from, see, I think we looked at that back here, didn't we? Yep. Back here again. Wow, come on. Okay. So it all comes from here. Reminder of that again. Okay. We've got the value of c is -4. The value of b here is negative pi over 2, which means our shift to the left. And now, the graphing of this then becomes a little bit tougher. So the first thing we're going to do is we're going to focus on the horizontal change first, because part of the reason why the letters A and B come first in the alphabet, they come first here. So we need to do our horizontal shift first. So since we're going to shift horizontally by pi over 2 to the left, that means that all these asymptotes I have here are going to be shifted to the left, pi over 2. So instead of my asymptotes being at 0, pi, 2 pi, they're going to be at negative pi over 2, pi over 2, 3 pi over 2. So the first part of my graph is going to be shifting my asymptotes over. So let's put our axes up here. Put all of our scales in. So we've got pi here, 2 pi, negative pi, and negative 2 pi. All right. In our asymptotes, because we shifted horizontally pi over 2 to the left, that means then now our asymptotes are going to be at all the pi over 2's. So now if we're looking at our graph, all right, we're going to focus on this section here first. The section that's between negative pi over 2 and pi over 2, which means that we're looking at the section here between 0 and pi. All right? So between 0 and pi, at this pi over 4, I had positive 1. If I take that positive 1 and multiply it by negative 4, what do I get? Negative 4. All right? So we're going to have, let's use the purple again. We're going to have at the pi, what was pi over 4 here is now going to be pi over 4 here. We're down at negative 4 there. Does that make sense? You understand that we're working that this section here is the same as this section here on this graph. These are the same. Okay, because all I'm doing is I'm taking it, moving it to the left, pi over 2. So then where it was 0 here, what's 0 times negative 4? Okay, it's still going to be at 0. And at 3 pi over 4, where it was negative 1 times negative 4 is 4. Okay, so we're at 0. And at pi over 4, then we would be at positive 4. So our graph is going to look like this. And then it'll look like that in each section. Oops, got my... And there's that graph. All right. So the graphs you're going to be making are going to just be transformation. So you're going to be doing vertical stretches, and we're going to be doing horizontal shifts. And so the thing is when you do the horizontal shifts, always do that first. So you move your asymptotes, and then I compare. Okay, what does this go with? All right, which section of my graph am I going to move? And then just multiply the y values by whatever the stretch or compression is.